So, my name is Yogesh Khedar, and today I will be talking to you about fleet management and automated drone operation. Let me share my slides. We already had some idea about these two topics. So, first, the talk by Tridge in his keynote, uh, where we saw that multi-operator operation of an autonomous buoy is a real use case, as well as the really good talk by Mena Delivery talking about the automated operations. I'll be talking on these topics in the context of our software platform, on which I come in a bit. We all know drone operations are very complex. They have different stages. So before flight, you have to do a lot of steps, planning, checking the weather, making sure that the geo zones are all okay. Then you have to fly. You have to take care of the logbooks, the logs. You have to do the actual flight, and then the data capture sometimes also has to be done manually. After the flight, also you need to make sure that everything went good. You have to store the data and carry out data analysis. Since that data analysis is like the most often use case of using drones. We have been working on drone operations for a long time, on both on research projects as well as commercial projects, and we have realized that this is a really big problem if you want to do it more regularly. So for the past 3 years, my company, Outrick, of which I'm a co-founder and CEO, has been working on solving this problem. And we created a platform which is called Outrick OS, which allows you to control or manage your fleet from anywhere in the world, as well as carry out automated operation. So single app to carry out all the stages of drone operation, planning, flying, controlling, getting the data synchronized to the platform, as well as automated analysis. This reduces operation errors, so everything is happening in the same application. It's also much more efficient, and since the data is in the cloud, all aspects of compliance can also be taken care very easily. How it all works. So the architecture is based on cloud native technologies. So we have a backend, a server which can either sit in a publicly hosted cloud or on premise, running a Kubernetes cluster, and all the microservices related to managing different aspects of your operation as well as fleet are hosted there. Then there's a client, which we name Sky Client, which is usually run on a companion computer on the drone. And we talk to the autopilot using various SDKs. So in the case of Mavic drones, we use Mav SDK. And for DJI, there are SDKs from DJI. We have also some open source projects. So we were also not the first one, but one of the first ones to add support for autopilot to Mav SDK. And now there's a repository where you can try out how Mav SDK works with autopilot, as well as the Golang client libraries to interact with the Mav SDK server. There's another possibility to control the drone. If the operator is in the field, then he or she has mostly a ground control station, and the Sky Client can also run on that, talking to the drone over the field link. The dashboard application, which is used to control all these aspects, is a multi-platform application. So you can install it on any major operating system, as well as you can use it also in the browser. The platform is multimodal, so you are able to control different kinds of vehicles, boats, rovers, drones, docks, for example, the DJI dock here. All of these are real use cases, which we are pursuing right now with our pilot customers in the private beta phase of our application. We also support Mavlink-based autopilots as Autopilot or PX4, as well as the DJI interfaces. Now coming to the fleet management aspect. So the first is the fleet overview, where you can see the various vehicles um, which are in your fleet. These can consist of traveling drones, as I said, or different vehicles, as well as normal security cameras or motion sensors specific for use for security applications. So one could configure, which is one of the use cases right now for us, for one of our customers, that one could configure a motion sensor to send out an alarm, and based on this alarm, flight can happen automatically. Uh, yeah. We also support STIL devices, so autopilot STIL or PX4 STIL, which can be used to simulate or train operators for various aspects of operations. All this information can be exported, which I mentioned before, the compliance readiness. So you can export what your fleet consists at the moment and what is the status of the fleet. Then individual devices. So, for example, the autopilot can be overviewed in this view, which were the previous flights, what is the status of each flight, and different parameters can also be configured. So you can also see all the parameters, as well as you can change the parameters along with the possibility to track the changes. So you are able to know what time which parameter was changed, which is very helpful finding out what could have triggered recent, let's say, behavior of the vehicle. Also available is that all the logs which are acquired on the device, they are also synced to the cloud platform, so that you are able to see it in the dashboard. You can do also plotting for individual plots, as well as download it for further analysis. The Sky Client UI, it allows you to configure the companion computer itself. So for example, you can configure different kinds of cameras, streams. Right now, Mavic, IP, Sony Alpha, as well as USB cameras are supported. Modems can also be configured, so APN related parameters, as well as logs coming from various services which are running on the companion computer. We use Docker Compose, so you can easily add new services to it, either directly as a Docker service or as a normal, let's say, executable or daemon services. Uh, you're also able to add offline map services. So a map service can provide offline maps, either terrain data um, or usual satellite imagery directly from your companion computer. So that was fleet management. Now, if you want to do an automated operation, first you have to really think about geozones. These can be custom custom geozones. So, for example, you can define something is a no-fly zone, or something is your operation area, which is like the geofence in Mavic dialect. Um, it could be also that you also, I mean, of course, you also want to add geozone data from your specific aviation provider. And this can be done using usual web app services, or there are other possibilities which also exist. Once you have GeoJones settled, now you would like to create a plan. You would do that in the plan management view, where you can add, delete, or edit different kinds of mission plans, as well as you can export them in different formats. The editor allows you to carry out very complex waypoint missions, allowing also to add actions for each waypoint, um, which is very helpful in creating sophisticated missions. Once you have a plan, now you would like to carry out a flight. So in the mission create view, you would create a mission. Mission could be scheduled for immediate execution, or they can be scheduled for a scheduled date. They can be recurrent, so every 1 hour or every 1 day. And they can be attached with pre-flight checklist. So if the pre-flight checklist is successful, the mission will be carried out. Otherwise, it will not be. This allows for unattended workflows for various kinds of use cases. Again, the flight information can also be exported in PDF format, which is helpful for carrying out various operation authorization processes. The control station allows you to monitor the mission as well as taking control in real time. It can be in the field or it can be in a controlled environment in office. And here you can see all the various vehicles which are online. Yeah. And one possibility is for security applications. For example, you would like to carry out real-time object detection. This is also possible by simply configuring what kind of object you want to detect in the video stream. What kind of you can also change with various settings so that you can optimize the object detection pipeline, as well as one of the example from the DJI dock use case, where you can also see in real time what the dock is doing. You can control the dock. You can also see video stream from all the devices from the dock as well as from the drone. You can also control the gimbal camera. We support mapping. Gimbal and camera can be controlled. Also the save settings. All the aspects of camera management is also there. You can also carry out manual flights. So simply execute a manual flight, and then all the checklist would be presented to you. You need to fulfill all the checklist as well as provide comments, and then the manual flight can take place. All the data which is being acquired by the drone is being synced either in real time or after the flight. And this is specific for each mission. So after that, you can trigger either manual photogrammetry or automated photogrammetry can be configured. So at the end, you get 3D models or different byproducts of photogrammetry, which can also be viewed in the same dashboard. Right now we are running private beta, which will run until 21st of September, from which date we will start our public beta. And at this point, also mapping missions would be supported, as well as automated photogrammetry pipeline combined with the object tracking module for video stream. Later on, we also plan to add more features, for example, ASIM-based flight simulation and training, firmware upgrade directly from the Skyclient UI, as well as offline map services. More important is also mission sharing, which is also really important feature. Thank you very much for listening to me. I would now take questions.
Thank you for joining us for the Arduino Pilot Developers Conference 2025. With thanks to our sponsors, 3DXR, Aerosystems West, CUAV, QPilot, High-Tech, Polybro, IR-Lock, KH Unmanned, Kraus Hamdani Aerospace, Maytech, Modal AI, Northwest Blue, SD Model, and Theseus. Organised by KH Unmanned. Hosted by 3DXR in North Yorkshire. Broadcast by Q Branch.